Okay, welcome to the live class on indices. So today I'll be walking through the very basis of indices, what they are, and how to use them in solving basic questions. So we're looking at indices. Now, first, we're going to look at the various rules, the set of rules in indices. Now, the first rule of indices is when you have a to the power of m times a to the power of n. Now, when you have the same base, a and a being multiplied to different powers or the same powers, depending on what it is, you take one of the base and then you can add the powers m plus n. Now, this is the first law of indices. Very easy to remember. The very first law of indices. Now, how does this really work? Well, consider it this way. If you have 8, means like 5 to the power of 3, and you multiply again 5 to the power of 1 or 5 to the power of 4. Now, this is going to be, you take one of the bases, which is 5, and then you add the power, which is 3 plus 4, which will be the same as 5 to the power of 7. Now, we can also use different numbers if we choose to. You could have, say 9 to the power 8 times 9 to the power of 3. Now, of course, if you have the same base, you take one of the base, and then you can add the power, which is 8 plus 3, and that's going to be 9 to the power of 11. In the same sense, we can also, we can look at this, if you have b to the power 10 times b to the power 6, this will be the same thing as take one of the base, which is b, and then add the power of 10 plus 6, and that will just be b to the power of 16. So this is the first law of indices being applied to simple problems. Now, let's look at the second law of indices. The second law of indices has to do with division, like if you have a to the power of m, and you divide it by a to the power of n. Now, this will be the same as a, the base a, and then you subtract the power, which is m minus n. Now, this is the second law of indices. Now, how does this really work? Okay, so we might say, consider if you have 6 to the power of 4, and you divide this by 6 to the power of maybe 2. Now, what you do here is take one of the base, and because you're dividing, you subtract the power, which is 4, take away 2, and that will be 6 to the power of 2. Now, we just want to leave our answer as a base to the power of 2, as a base to the power of 6, okay? In the same sense, you can have an example. Let's say you have, say, 9 to the power of 7, and you divide this by 9 to the power of, let's say, 3. Again, since you have the same base as 9, take one of the 9, and then you subtract the powers, which is 7 take away 3, which is giving you 9 to the power of 4. You could also have letters, okay? Like if you have, say, c to the power of 15, and divided by c to the power of 10. Now, this will be the same thing. You take one of the base, which is z, and then you simply subtract the powers 15 minus 10, which would definitely give you 5. So you have z to the power of 5. So this is the second law of indices. Now, let's look at the third law of indices. Now, the third law of indices could be, for me, I want to say, if you have a to the power of m, and this is being multiplied by another power n. Or should I say, yeah. So if you need to simplify this will be, you take one of the base, and then you multiply the powers, m times n. Now, I like to say this is the third rule of indices, okay? And how do you apply this? Well, let's say a is a number like 2 to the power of 5, and hold this in the bracket to the power of 3. Now, this will be the same thing as saying take the base 2 and then multiply the power, which is 5 times 3. And that will be the same thing as 2 to the power of 15. We can take another example to explain a little more. Let's say you have to the power of 5. Don't use 5, let me use a different number. Let's say b to the power of 4. And then hold this in the bracket to the power of, say, 7. Okay, so basically, this will be the same thing as take one of the p's, and then you multiply 4 times 7, and you're going to get p to the power of 28. Okay, and let's take one more example to, to make this a lot more easy for some of us to understand. Let's say you got 10 to the power 6, and you hold this to the power of 3. Basically, what you need to do, take one of the base, which is 10, and simply multiply 6 times 3, and definitely that's going to be 18. So you have 10 to the power of 18. Now, we go to the next law of indices. Now, this one is going to be a lot easier to understand, and that could be two really, but I'll put them side by side. One of the rules is if you have a to the power of 0, now that will be the same thing as 1. This is a very simple law of indices, and I want you guys to try to remember this. It's pretty easy. A number or a letter raised to the power of 0 is always 1. Now there's another law, kind of let me split my screen into two here like this. There's another one that looks similar to it, but not the same. Don't you just spot the difference? If you have a to the power 1, this is the same thing as a. That's another law. Okay, so I just want you guys to try to remember this. Okay, and try not to confuse this one with the one on the left. Again, I will try to reiterate the differences. This is a to the power of 0. Now anything raised to the power of 0 will always be 1. Okay, but the other one on the right is a letter or a number raised to the power of 1 is the same thing as that letter or that same number. Okay, so I'm going to explain the differences with practical questions. Okay, say you have here 3 to the power of 0. Now anything raised to the power of 0 will be 1. In the same sense, if you have 5 raised to the power of 0, well, that again is definitely going to be 1. Even if you have the letter m raised to the power of 0, again, that will be 1. Okay, but this one on the right is if you got let's say 3 to the power of 1. Now 3 to the power of 1 is the same thing as 3. Okay, and if you have 7 to the power of 1, this is the same thing as 7. You could even reverse it the other way around. If you could see something like this is 10. Now 10 is the same thing as 10 to the power of 1. It's basically the same thing. Okay, so these are the difference between these two laws. Okay, the rules are the rules for indices. They're quite easy. Now the next one I want to bring to attention is one that has to do fractional indices. Usually for students in year 10 or year 9, that's when you move into this. So let's say you have, this is the rule I'm trying to show you guys. If you have a to the power of m, okay, let me put it clearly in a simple way. A to the power m over n. I hope you guys can see that letter m. It doesn't look so clear to me. A to the power m over n. This is the same thing as the nth root, okay, of a, and hold this in a bracket to the power of m. Now that is what we call the fractional indices. Now, how does this really work? Well, let's look at an example. Say you have 27 raised to the power to third, and you need to simplify this. Now, this will be the same thing as this 3 will be the cube root of the cube root, okay, of 27, and the whole bracket to the power of 2. Of course, you do know that the cube root of 27 is 3, and then raise that to the power of 2, and 3 to the power of 2 definitely will be 9. Another example you could consider is if you have, say, 32 to the power of, let's say, 3/5. Again, what we do the 5th root of 32, the 5th root of 32, and hold it in the bracket and raise it to the power of 3. Now, the 5th root of 32 is definitely going to be 2. And again, you raise it to the power of 3. Now, this to the power of 3 is the same thing as saying 2 times 2 times 2, which is definitely going to be 8. Okay, it's going to be 8. Now, we can take one more example to even make it much more easier for us to capture. Let's say we have, I want to simplify 64 to the raised to the power of, let's say, 3/2. Okay, fraction indices. Now, this will be the same thing as doing this, the 2 square root of 64. Put 2 here, this 2, square root, and put 64 right under the square root sign, and then hold this with the power 3. Now, of course, you work out the square root of 64. Definitely, that's going to be 8. And remember, to the power of 3. Now, 8 to the power of 3 simply means 8 multiplies itself thrice. That's 8 times 8 times 8. Now, if I work this from the background, 8 to the power of 3, I will be getting something like 512. So 8 to the power of 3 is 5 to the 512. Okay. All right. So that's for that. There's another rule of sorts that and there's a rule of indices I need to also explain. And I think it's this one here. If you have a to the power of minus m, okay, this will be the same thing as 1 over a to the power of m. Now, I want you guys to take note of this. Okay, take note of this. A to the power of minus m is the same thing as 1 over a to the power of m. Now, how do we really apply this rule? So, say we have 2 to the power of minus 3. Now, this will be the same thing as 1 over 2 to the power of 3. And if you simplify this, this will be 1 to the power of 8, because 2 to the power of 3 simply means 2 times 2 times 2, which is 8. In the same breath, okay, but I have to split my screen so I can take some more example here. Okay, say we have to work this out. Say 4 to the power of, let's say, minus 3. Now, this will be the same thing as 1 over 4 to the power of 3. And if you simplify further, 1 divided by, now 4 to the power of 3 means 4 times 4 times 4, which is 16 times 4, 64. So it'll be 1 over 64. Let's take more example. The more we do example, the more you get a lot more confidence solving some of these problems. Let's say you have 5 to the power negative 2. Now, this is the same thing as saying 1 divided by 5 to the power of 2, which again, if you simplify, it'd be 1 over 5 to the power of 2, so it means 5 times 5, which is 25. Okay, so you can see how this is applied. So in a retrospect, let's back up and see some of the rules that we have looked at in the past few minutes. Okay, so we looked at the first rule. Okay, when you have the same base multiplying with different powers, or the same powers depending, you simply take one of the base and add. That's the first one. The second one, when you're dividing, you subtract the powers. The third one, if you have a to the power of n, multiply 1 on the power n. it gives you this. And then we'll look at the fourth and fifth one, put side by side, just to clarify. And then we'll look at also this rule, fractional indices, and how we worked it out. And then we also looked at negative integer indices, and we saw how we worked it out. So in this slide, we're going to apply the different ways some of this question can be set in an exam, or maybe in a classwork, or even in a class test. Okay, we're going to see how these questions can be, sometimes have one question with one rule and another question with different rule kind of mixed up. So we want to see how that is done. So let's say I want you to simplify. Let's say 4x to the power 3 times 5x to the power of 7. Now, basically, how you can do this, if you need to show the steps, the first thing, we have to multiply the coefficients. That's the numbers right behind the x's. So I'll multiply the 4 times the 5. And then again, you now take the x's, x to the power of 3 times x to the power of 7. Now, when we multiply 4 and 5, you get 20. And then this is the first law of indices, x to the power of 3 times x to the power of 4. Okay, that will be x to the power, you add the powers, 3 plus 7, which is 10. Now, of course, to make the tidy our work, I would simply just write this as 20 x to the power of 10. Now, you immediately notice that I kind of, somehow this times here just disappeared, right? Okay, well, it's still there, but just that we just have to take it out of, the writing just to simplify and put our work in a tidy form. I hope you understand that. Thank you. Thank you. So let's move on to the next example. Let's say I want us to simplify this. Let's say 20 x to the power 7 and divided by, say, 4 x to the power of 5. Now this is divide. So what we can do is this. We can write it as a fraction form as 20 x to the power 7. And of course, you're going to divide that as a fraction as 4 x to the power 5. Now, if you're going to work this out, you really immediately notice that we can separate the 20 and the 4, and also separate the x to the power 7 divided by x to the power 5. Obviously, you can see something very interesting, that 24 into 20 will give you 5. So you have 5 here, and x to the power 7 divided by x to the power 5 will be x to the power of 2. Remember, when you're dividing powers of x, when dividing x's with the powers different, you separate the power when they have the same base. So the answer is going to be 5x to the power of 2. Another example you might see is you could put a question like m to the power of 4 times m to the power of 3, and you've been going to divide this by m to the power of 2, and you want to simplify this. Okay, now to simplify this, the first thing you might want to do, you might notice that you have m and m to the power, different bases, but they have the same base. So you might just take one of the m on the top and add 4 plus 3, which is 7, and divide that by m to the power of 2. Again, you can see this m to the power of 7 divided by m to the power of 2. They have the same base. So you take one base and then you separate the powers, which is 7 to the 7, take away 2 will be m to the power of 5. Pretty straightforward. Similarly, you could have a little complicated one. Not because it's complicated, because it's going to be complicated because you have the minus, really. That's why. You could have p to the power of 9 times p to the power of minus 2. And you're going to divide that, let's say, p to the power of maybe 4. So if we're going to simplify this stuff, what you might want to do is to start with the top, and you start with P. You have the same base, take one with P. And because you're times in, you're gonna say 9 plus minus 2. Now that's where I really want to get your attention. This is 9, because you're times in, this is gonna be plus, and then of course the next is minus 2. And of course you're gonna divide this. Okay, you're gonna divide that by P to the power 4. Now again, if you simplify this, when you have a plus and minus kind of together like this, it changes to minus. So this is going to be P to the power 9 minus 2. That's P to the power 7 divided by P to the power 4. Now, P to the power 7 divide P to the power 4 will simply be P to the power of 3. Again, because you have to separate the powers. Now, let's move on to another example, which I think has to do with fractional indices. Now, let's say you have 6, and easy to simplify 32 raised to the power 2 over 5, and need to simplify these fractional indices. Now, what we could do is we will put this as the 5th root of 32, close the bracket, to the power of 2. Now, the 5th root of 32 is 2, and raised to the power 2, which will be 4. Pretty straightforward. Now, we can take another example. Let's say I want to simplify. Let's say I want to simplify 64 to the power of 3 over 2. Okay. So what we do here is, again, the similar thing we do as of previous. You do, I put a square sign, but then the 2 comes right here. So that's like square root of 64. And close the bracket to the power of 3. Now, the square root of 64 is 8. Okay. And 8 to the power of 3. Now, if you use your calculator, 8 to the power of 3, 8 times 8 times 8 will be 512. Pretty straightforward. And let's take one more example. Another example here could be, you could have, I needed to simplify 81 raised to the power half. Okay. So if we're going to do this, basically, again, we'll go through the steps and we'll put the square root sign. Now the 2 here is the square, so you put the 2 here, put 81 right under the square root sign, and hold this with a bracket and raise it to the power of 1. So here you can see the square root of 81 is 9, and 9 to the power of 1. Now, of course, 9 to the power of 1, we saw that in one of indices laws, will be the same thing as 9. Pretty straightforward. Now, the next one we're going to consider is similar to this, but it has a negative fraction in the power. Let's see how that really works. Say I want you to simplify. Let's say you have 49 raised to the power of negative half. Okay. Now, to get this done, what we might want to do is to start out with the same laws of indices. You put the square root of 49, put this kind of 2 here, and hold this with a bracket to the power of -1. Now, of course, if you do the square root of 49, that's going to give you 7, and then have -1, the power here, -1 you also include it here. Now, 7 raised to the power of -1, if you remember one of the laws, the rules of indices we looked at, this will be the same thing as 1 over 7. Pretty straightforward. Now, we can develop more on this by looking at an example. Let's say you have, let's say use the same number, but let me use a different number, really. Let's say you have simplified 32 raised to the power -2 over 5. So the first thing we need to do is to do the 5th root of 32. Okay, the 5th root of 32. And then hold this the bracket of -2 here. Now, if you work out the fifth root of 32, obviously that's going to give you 2. And of course, remember to add the power of -2 here. Now, this to the power of -2 is the same thing as saying 1 over 2 to the power of 2. And that will be 1 over 4. Okay. Now, I'm going to give you guys one question, and I want you to work it through, and then I'll give you maybe 10 seconds to do, and then you tell me the answer. Okay. All right. So if you have this question, I want you to work this out. Simplify 64, okay, to the power of -2 over 3. Okay. Okay. I want you guys to work this. I'm going to give you a minute to do. Go ahead. I'll be back in a minute. Okay. I hear some people say they've got the answer. Okay. Congratulations to you if you got the answer, but I have to work it with you so that we can confirm. Okay. So basically what we do, because this is the power 2 over 3 here. So I put this to the cube root and put 64 right in here, and then put this to the power of -2. So you want to do the cube root of 64. The cube root of 64 is definitely 4, okay? 4 and raised to the power -2. And this is same as 1 to the power of 4 squared. And that's same as 1 over 16. So congratulations to you. If you go 1 over 16, a big congratulations to you. It's so good when you solve and you get the answer. And you're so sure about that. Good. Now, I'm just thinking if there's another question. I'm not sure there's another question, but I'm very happy that you found these exercises on the laws of indices explained in this very basic form. I want to thank you guys for joining. And if you have any observation and any comment, anything you think might be helpful for every other person joining this live class, I want you to put it in the comment section, and I'll be reading them and I'll respond to some of them. Thank you.